everyone, welcome back to my channel Explore with Aditi Vyas. In today's video, I'm going to discuss about nitric acid, your chapter number 10. Alright, but before that, if you are new to my channel, please subscribe to it and watch the video till end. If you like it, then share it with your friends. Now come to the nitric acid. The molecular formula of nitric acid is HNO3 and the molecular mass is 63. Alright, we all know that nitric acid is a volatile acid. Alright, and H2SO4 is non-volatile acid. Now come to its introduction and discovery. So it is known as Aqua fortis because it is a strong water or very strong acid. Alright, it is so called because it reacts with nearly all metals. Alright, it dissolves in silver which does not dissolve in other acid. Alright, simply means it directly dissolves silver. Alright, now come to the next point. Cavendish in 1784, here it is 1784, proved that HNO3 has hydrogen and nitrogen as well as oxygen. Now come to its occurrence. In free state, nitric acid is found in rainwater. Alright, and in combined state it is found in form of metallic nitrates. Then the formation of nitric acid in atmosphere. So the nitrogen is present in our atmosphere and react with oxygen to form nitric oxide. Then this nitric oxide further oxidized to form nitrogen dioxide, and this oxygen is also present in our atmosphere. So here the nitrogen dioxide formation take place. Now this nitrogen dioxide dissolve in atmospheric moisture or rainwater that is present in our atmosphere in the presence of oxygen and lead to the formation of nitric acid. Alright, now come to the lab preparation of nitric acid. If I talk about the lab preparation of nitric acid, then sodium nitrate is reacted with the concentrated H2SO4 below the temperature 200 degrees Celsius and lead to the formation of HNO3 in the formation of vapor and formation of sodium hydrogen sulfate. Then this nitric acid is volatile in nature and this concentrated H2SO4 is non-volatile in nature. So here the question arises, why only H2SO4 is used in the preparation of nitric acid and not HCl? So we already know that H2SO4 is non-volatile and in case of HCl it is volatile. So it will combine with these nitric acids which are volatile in nature. So here we are using H2SO4. Now the next question is why temperature is below 200 degrees Celsius. There are two main reasons or three main reasons. The first one is at high temperature or more than 200 degrees Celsius temperature, sodium sulfate formation occur and which is very hard. So this reaction is not possible, and at high temperature nitric acid decomposed. Alright, and it will lead to the formation of NO2 plus H2O and oxygen, and fuel is wasted. Then the next one is we all know that nitric acid is colorless. Then why the color of nitric acid, freshly prepared nitric acid, is yellow in color, or what is the color of nitric acid? Okay, so it is yellow in color, and the reason is like nitric acid is decomposed. Alright, and nitrogen dioxide is reddish brown in color. It will dissolve in solution and lead to the formation of yellow liquid. So freshly prepared nitric acid is yellow in color. Then the next question is why glass apparatus is used in preparation of nitric acid. The reason is we all know nitric acid is very strong oxidizing agent. So HNO3 is very corrosive. Okay, like it will decompose many things. So glass apparatus is used because it will not going to damage that. Then come to its properties. It is colorless. Okay, but only fresh HNO3 is yellow in color. Corrosive, which means it is a strong oxidizing agent and it is very strong acid. Then reaction with base, of course it is a strong acid, so it will lead to the formation of neutralization reaction. And in case of neutralization reaction, acid react with base to form salt and water. Then come to the reaction with metal carbonate. Metal carbonate will react with the acid and lead to the formation of salt plus water and carbon dioxide. In case of sulfides, it will form sulfur dioxide. Then the most important reaction is nitric acid is strong oxidizing agent and never react as reducing agent. It will never going to act as reducing agent. So here is the reaction of HNO3 as oxidizing agent. It will react with carbon to form weak acid H2CO3. So it will give H2O plus CO2 plus NO2. And in case of sulfur, it will form sulfuric acid, which is very strong acid. Then the reaction with metal or reaction with copper. Very important reaction. When the dilute HNO3 react with copper, it will lead to the formation of nitric oxide, while in the case of concentrated, it will lead to the formation of nitrogen dioxide. Alright. Then reaction with metals, because HNO3 is very strong oxidizing agent, so it will not going to liberate hydrogen as other metals do. As we all know that whenever metal react with acid, it will liberate hydrogen. But in case of HNO3 or nitric acid, it is very strong oxidizing agent. So as it liberate H2, it will further react with oxygen and lead to the formation of this H2O. Okay, but exceptions are always there. So whenever it will react with magnesium and manganese, it will form H2 because these are thermodynamically stable, but it is only happen in the case of very dilute HNO3, which is 1 to 2%. Then come to the test for HNO3. HNO3 when heated, it will give NO2, which is reddish brown in color. But there is one more important test, that is brown ring test. When concentrated H2SO4 and FeSO4 is added in the test tube in which HNO3 is added, then it is cooled in the tap water, and here a brown ring is formed, which confirm that HNO3 is present. Then whenever nitric acid is prepared at a large scale or in industries, there is one process involved, that is your Ostwald process. But we are not going to discuss this process here because we had already discussed this in ammonia chapter. If you have not watched that video, please check it out in the playlist. Then directly come to the uses to dissolve novel gases. Very important uses of nitric acid is it will going to dissolve novel metals, okay, which are very non-reactive, that as silver, gold and platinum. But silver is directly reacted with HNO3. But in case of gold and platinum, we are using Aqua Regia, which is very strong acid. Here the ratio is 1:3, 3 ratio of acid. All right. And it will give us nascent chlorine, which is highly reactive, and then this nascent chlorine will react with these novel acid and lead to the formation of AuCl3 and PtCl4, which is very soluble. So this is all about nitric acid. I hope you all understand it. Thank you for watching.